In this video, we are going to find the maximum value of x to the power 4 minus x squared all divided by x to the power 6 plus 2x cubed minus 1 over x larger than 1. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. There is a very simple trick that allows us to find the maximum value of this expression very quickly, which is to divide both the numerator and denominator by x cubed. So in that case, we have x minus 1 over x for the numerator, while for the denominator, we have x cubed plus 2 minus 1 over x cubed. The reason that I decided to do this is that I can actually express x cubed minus 1 over x cubed in terms of x minus 1 over x in a very simple way. Indeed, if I let u equals x minus 1 over x, then if I cube both sides, then I have u cubed equals x cubed minus 3x plus 3 over x minus 1 over x cubed by the binomial theorem. And in fact, this part, minus 3x plus 3 over x is exactly minus 3u. So therefore, x cubed minus 1 over x cubed is equal to u cubed plus 3u. So our original fraction now equals u over u cubed plus 3u plus 2. Now at this point, there are two ways for us to find the maximum value of this fraction. The first way is that I'm going to consider the function u cubed plus 3u plus 2 all divided by u instead, the reciprocal of the required fraction, because I can just rewrite that as u squared plus 3 plus 2 over u, and I can use calculus to help find the minimum. I was originally asked to find the maximum for this, so if I take reciprocal, I'm supposed to find the minimum instead. Then I differentiate, have u 2u minus 2 over u squared. Which equals 0. So simplifying, we should have u cubed equals 1. And so u equals 1. Because I'm looking for real values of u. So we can also further test that this is indeed the minimum by differentiating again. Which gives 2 plus 4 over u cubed, and somehow that should be equal to 2 plus 4 over 1, and that's positive. That means it's really a minimum by the second derivative test. So that means the minimum is obtained when u equals 1, so the minimum value equals 1 plus 3 plus 2 over 1, and that's equal to 6. So given that the reciprocal has a minimum of 6, that means the maximum value is the reciprocal of that, which is 1 over 6. So that's the first way to find the maximum. The second way is relatively simpler, which is that I can actually make use of so-called AMGM inequality, which says u cubed plus 2 can be split into u cubed plus 1, and that's larger than or equal to 3u by the AMGM. So therefore, the denominator is at least 6u, and that means the given fraction is less than or equal to 1 over 6, equality holds when u equals 1. So from these two approaches, we can also obtain that the maximum value is 1 over 6. The last question is, what's the value of x when this minimum value is attained? So we know that u equals 1, and equivalently, that means x minus 1 over x is equal to 1 by definition of u. So with a quadratic on x, and we have x equals to either 1 plus root 5 over 2 or 1 minus root 5 over 2. But of course, we reject the minus case because we want x to be larger than 1. So the maximum is 1 over 6, which occurs when x equals to 1 plus square root 5 over 2. Please feel free to share ideas in the comments. Thank you for watching. See you next time.